Hey guys, just wanted to make this quick video showing the evolution and thought process behind my newest X-ray cracking design in Dyson Sphere program. The X-ray cracking recipe, you can see there at the bottom left, is 1 refined oil in and 2 hydrogen in, and then it has 3 hydrogen out and 1 energetic graphite out. So when I first started to design a production line with this, I did a line for the refined oil in, a line for the hydrogen in, and I do a line out for hydrogen and a line out for energetic graphite. And it works. It's self-contained. You don't need to transport hydrogen in. You just need to kickstart it with hydrogen. So if I load some hydrogen in here, it's going to start working. And you'll notice the hydrogen always gets pumped back into the system, or it prioritizes being pumped back into the system. Now eventually, when this fully is kicked off and it kind of slowly boots up all of the products, eventually the hydrogen will start exiting the process and actually outputting a net gain of hydrogen. But for now, it's just spends some time kickstarting itself. So this is a great design, and you can see that you can expand it as long as you want, or not as long as you want, but you can expand it back. And the limitations of it comes from how much you can expand it. So, this game is about finding the weakest link, the bottleneck, right? So in this case, eventually, as you expand this, you're going to hit a bottleneck on the belt capacity because the output is 3 hydrogens. And the way to calculate this is look at the rate of everything. And you have to do some conversions because the belt is, you can see there, 30 items per second. And the production of this factory is 15 per minute. And since it's outputting 3 hydrogen, that's outputting 45 hydrogen per minute. So at this point, you need to go to the calculator and say, well, how many facilities do I need, or can I fit before the belt is maxed out, right? And that's using division. So you take the belt capacity divided by the output of 1 facility. The belt capacity is 30 per second. So if you convert that to minutes, you multiply by 60, and that's 1800 per minute. So you do 1800 divided by 45, and you get 40. Remember, you divide by 45 because that is the hydrogen output, and hydrogen is the largest number of output. It's 3 output units. So that basically tells me that this can expand back 40, and anything beyond that is going to be wasted energy because it's going to max out the belt. So in this demonstration, I've actually already created it all the way back as far as it can go, which is 40 facilities, you can see there. So this is the design, and it's not a bad design. It works pretty well. You can see the energetic graphite going in. You can see every once in a while you might see a hydrogen go in. Eventually this will be a full belt, and you'll have 600 per minute hydrogen going in and 600 per minute energetic graphite going in. So what that means for the refined oil is you have 600 per minute refined oil going out. So my thought process was, it seems like there should be a better way to do this, because I like to build things that have the full throughput of the belt in and out. If you look back at the recipe again, the net input and output of this is 1 refined oil, nets out 1 hydrogen and 1 energetic graphite. So I wanted to come up with a way that just have a full 1800 per minute refined oil in, and then a full 1800 hydrogen out and a full 1800 energetic graphite out. And turns out there is a way to do it, and that is shown by this facility here. So just looking at the end, so forget about what's to the left, it's going to be a lot of facilities obviously, but just looking at the belts, maybe not perfect. You see a gap every once in a while, but it's essentially 1800 refined oil going out and 1800 hydrogen and energetic graphite going in. And the funny thing is the design's even slicker, right? There doesn't have the splitter. There's only 3 belts total. And the way it works is essentially having hydrogen in and out on the same belts, which honestly should have been obvious to me from the beginning, but it wasn't. And the way this works, I'll show you. So here's the last line of the production. The way it works is you have to output the hydrogen upstream from the input of hydrogen. So it's outputting here and it's inputting there. I'll actually demonstrate this over here on this short stack. Do the autosave. So if I just kickstart this real quick, you can see it's going to output here and it's going to re-input here. Now the problem with this, because my first thought process was, here I'm going to, whoops. My thought process on this was, okay, well, I should just be able to do this and then copy it a bunch of times, right? But that actually doesn't work. And I'll demonstrate why in a second. So essentially what this does, if you look at this one production here, and the fact that you're outputting hydrogen and inputting it here, the hydrogen that goes past the facility is really just one. So it's 1 per production cycle. So it's actually, instead of doing 45 hydrogen per minute on the output, on the net, it's just 15 per minute on the output. So that calculation we did earlier, as far as when the belt's going to get maxed out, you can actually do it 1800 divided by 15 instead of having to divide by 45. And that's 120. So that's a whole bunch more facilities. And you can see this production line here that's currently running. I'll show you the whole thing. If we select it with the blueprint, it goes all the way around the world, literally. Although I am sort of in the northern hemisphere, but... And then I actually go down a little bit here just so it doesn't collapse into itself. But here we go, all the way around. That's 120. Now the trick here is I actually my first try at this was to have this design where it's outputting upstream from the input, and I just copied it 120 times, but it doesn't work that way. And that's because this little distance between here and here on the last facility doesn't actually have the belt capacity to handle it. So what will happen is the last 2 facilities in your line of 120 won't be able to output hydrogen and it'll get clogged up. However, you really don't need every facility to have this upstream output setup. You really just need the first one, right? Because, so here I'll demonstrate by kicking this off. So it's gonna do this for a while until it gets some kind of internal buffering. But eventually it's gonna start outputting hydrogen onto this line. Now you see the next facility is set up differently. This is set up so it inputs and then outputs further down the line, which the setup removes the issue with the belt capacity. But remember, this on the net is outputting 15 hydrogen per minute. And this guy, when you look at the formula, it actually requires 30 hydrogen per minute as input. You can see that because it has 2 hydrogen as the input. So this setup doesn't work either, because this second facility is not getting the benefit from getting input from its own output, and it doesn't have enough output from the previous facility to actually fund its input neat. But, I mean, this isn't that complicated. Basically, you just have to switch this one to be set up like the first one. So now you have two of them that are sort of supplying its own input. And then all the other ones, the other 118 facilities can be the other setup where the output is downstream. So that was a lot of talking. It doesn't really need to be exactly that way. It just has to be that the last couple facilities cannot use the upstream output because that will screw it up. And then the other requirement is that the first two have to use the upstream output. And that's it. It's a nice skinny design. You can just stack the facilities here. It only takes up a couple tiles on the width. You could even make it even skinnier by putting the power in the middle. Sometimes you can put power poles in between here, but you know, I'd recommend doing something like this if you want to make it even thinner. And then you can make multiple rows of this and really get a huge production going. But anyway, that is my X-ray cracking setup, and I hope you like it. Thanks for watching.